So from the very first one, there are some of the definitions that you need to memorize. So those definitions include the definition of, for example, wavelength, frequency, time period. uh, then you have wave fronts, wave speed, wave motion. These kind of definitions that need to be memorized. So this is pretty much everything that you already study in O levels or IGCSE. Now the new thing is the formula and the relationships of intensity and amplitude. Intensity is defined as power over area. Intensity for a wave is defined as power over area. It can also be written as intensity equals to energy per unit time per unit area, because power itself equals to energy over time. Intensity is proportional to square of the amplitude. Very important formula. The questions can be solved using cross multiplication. On one side you have, let's say, one intensity, and on the other side you have a certain amplitude. So for example, previously the intensity was let's say 1.5 and the amplitude was 3. Now the amplitude is 5. What is the new intensity? How do you solve this? So previously the intensity was 1.5 and the amplitude was 3, but you write square of 3 because the expression is related by square, and the new intensity is x and the new amplitude is 5, but you write square of 5. After this you simply cross multiply. So 9 into x equals to 25 into 1.5, and from there you can find the value of the new intensity easily. The same formula can also be written as, if you want to avoid ratio method, you want to write simple formula, I1 over I2 equals to A1 square over A2 square. It's just like the formula of drift speed. Drift speed V1 over V2 equals to D2 square over D1 square, because the greater the cross section area, the lesser the drift speed. But for this case they are directly proportional for intensity and amplitude. Intensity is inversely proportional to square of distance from the source of the wave. Now this one can be written as I1 into D1 square equals to I2 into D2 square. So where do we use this? We use it when intensity at a certain distance is given, and now we need to find the new intensity at a given distance, at the new distance. Or the two intensities are given, one distance is given, now you need to find the new distance. Another expression is the relationship of amplitude and distance from the source. So they are inversely related. So this one can also be written as A1 into D1 equals to A2 into D2. Just like pressure is inversely proportional to volume, then you can say P1 V1 equals to P2 V2. Then you have the topic, if you need to find resultant amplitude, add the two amplitudes of the two waves. This is in accordance with the principle of superposition, which says the resultant amplitude when two waves meet up at a point, or when two waves meet, the resultant amplitude is the algebraic sum, the resultant displacement at a point is equal to the algebraic sum of the individual displacements at that point. After this one, we have let me just open up this one. Polarization. Phase. So if you need to find phase difference between 2 points, we use the formula to find phase difference between 2 points: delta t divided by time period multiplied by 360 degrees. So how do we use this? So you use it if you're provided with displacement time graph. So let's say the wave looks something like this. You need to find the phase difference between this point and this point. So you find the value of the difference of, let's say this is your point 2, this is your point 6, and this is, let's just assume, random 1.3. So what is delta t? Delta t is the difference between the 2 points for which you need to find the phase between A and B. So 0.4. What is the time period? 1.3 multiplied by 360. This is how you find phase difference between 2 points. If instead of displacement time graph, they give you displacement distance graph, then you use the formula slightly differently. Instead of delta t, you use delta d, the difference in the distance, divided by wavelength multiplied by 360. So phase difference between 2 points and phase difference of a phase of a single point, phase difference between 2 points, and phase difference between 2 waves. The last variation is phase difference between 2 waves. So let's say you have one wave that looks something like this, and the other wave that looks something like this. How do you find the phase difference? So very easy, you use the same formula, delta t in this case divided by capital T multiplied by 360. Let's say one wave is completed in 0.5 seconds, so that is time period, and the time period for both of the waves should be same. Only then you can find the phase difference between 2 points. And these kind of waves are known as coherent waves, the waves among which the phase difference remains same throughout. If it is 90, it remains 90. If it is 180, it remains 180. Now what is capital T? 0.5. Of both the waves, it should be same. What is small t? The difference between two corresponding points, consecutive two corresponding points. For example, peak of the first one and peak of the second one. What is the difference of time between these two? That is delta t. So I can assume, let's say this is your 0.18 for example. So that would be your delta t. There you have Doppler's effect. So where do you use it? Whenever there is relative motion between source and observer, then the observed frequency is different from the source frequency. The formula is given on the data sheet also. V over V plus minus Vs into Fs. F naught is the frequency of the observed frequency. Fs is the source frequency. V is the speed of sound. Vs is the speed of source or the speed of observer. So technically it's the relative speed. So might be observer is moving, and it is also possible observer is at rest and the source is moving. So both situations are possible. If they are moving towards each other, or source is moving towards the observer, you use a formula with negative sign. You use with negative sign, V minus Vs. If the source approaches the observer or the observer approaches the source, if they are moving away from each other, they are receding, source is moving away from the observer, then you use with the positive sign. Then you have topic electromagnetic spectrum, in which you need to memorize everything, all the frequencies and all the uses of the electromagnetic waves from the spectrum. So if you memorize all the wavelengths, you can easily find the frequencies using V equals to F lambda, because V is always 3.0 into 10 to the power 8. For polarization, so polarization is simply restricting the oscillations to a single direction. Restricting the oscillations of the particles in one direction only. It works only with transverse wave. Only for transverse wave. And we have very important formula for this one. I equals to I naught cos square theta. This is also written as I is the transmitted intensity of the transmitted wave. I naught is the incident intensity. Theta is the angle between transmission axis and polarizer. Transmission of axis of polarizer and analyzer. Analyzer means the second polarizer. So this formula is applicable only for the polarized light. Once the light is polarized already, let's say the intensity was 100 watts per meter square. After you place the first polarizer, intensity will be reduced to half always. So after the first polarizer, intensity will be reduced to half. But once you place the analyzer, what will be the new intensity? We don't know. That's where we use the formula. So I is the intensity after the analyzer. I naught will be this one, and theta would be angle between the first polarizer axis and analyzer. So when the analyzer is placed perpendicular or parallel to the polarizer, the intensity is maximum. So the graph looks something like this. Here you have intensity, and here you have angle theta in degrees. So this one would 0, this one is 90, this one is 180, this is 270, this one is 360. So many times they ask you to find the ratio of the amplitudes. So you use the same formula, I1 I equals to I naught cos square theta. So the angle could be given, and from the given angle you can find I over I naught, and once you find I over I naught you can easily find amplitudes like this, a square over a naught square. So let's say the answer of I over I naught was 4. Now you need to find the ratio of the amplitudes. Simply take square root of this. So for harmonics, for stationary waves, there are certain conditions that the two waves should be traveling in opposite direction. One of them is incident, the other wave is reflected. When two waves meet or overlap or superpose, then at certain points they form nodes, and at certain point they form antinodes. So nodes will be formed at the points where the phase difference between the waves is 180 and the amplitude is minimum. At those points antinodes nodes are formed, and the points where the phase difference is 0, the amplitude increases to maximum, nodes are formed, antinodes are formed. Stationary waves can be produced in three different ways. Three different ways. One is both ends closed, the other one is both ends open, the last one is one end closed, one end open. The last one looks something like this. So the lowest frequency, called fundamental harmonic, produced in the first cases looks something like this. So what is the case? Between two closed ends, aka between two nodes. This one is between two open ends or between two antinodes. The last one is between node and antinode, or between a closed end and open end. If you need to find frequency of first harmonic, second harmonic, third harmonic, any harmonic of the first case, you use the formula NV over 2L. If you need to find the frequency of any harmonic of the first case. L is the distance, or you can say the length of the tube. V is the speed of the sound or speed of the wave. Sorry, in this case, speed of the transverse wave. For first harmonic, n equals to 1. For second harmonic, n equals to 2. For third harmonic, n equals to 3. When two ends are open, then the lowest harmonic looks something like this, like an hourglass. If you need to find frequency of any harmonic, you use this formula, same one. And the same formula can also be used to find wavelengths. So for example, you need to find the wavelength of the second harmonic. So you say V equals to F equals to V over lambda, that equals to NV over 2L. Since you need to find the wavelength of second harmonic, you get 2 here. V cancelled out, so lambda equals to 2 also cancelled out, lambda equals to L. That's it. For the third case, the smallest frequency possible looks something like this. So the rule of thumb is, at the closed end, there should always be a node. At the open end, there should always be antinode. So antinode here, antinode here. At the open end, antinodes, and at the closed ends, you always have nodes. So node here, node here. If you need to find any frequency of this harmonic, you can use the formula 2n minus 1v over 4l. If you need to find frequency of any harmonic of this case. So for example, if you need to find for the first one, the value of n should be 1. And if the value of n is 1, you can find the value of frequency, which would be 2 minus 1, 1. So V over 4L. The next harmonic will be formed at 3V over 4L. The next harmonic will be formed at 5V over 4L. Likewise, you can find the wavelength also. Wavelength of the second harmonic would be use the same method. Put V equals to F over lambda. V and V would be cancelled out. Make lambda the subject and insert the value of n. The stationary wave oscillates up and down or left and right. So for example, we have a stationary wave that was initially like this. And this is, let's say, displacement time graph. So the stationary wave moves up and down. So this wave will move all the way to the bottom, and then it'll move all the way to the top, and it will make one complete cycle in a time which is known as time period. So let's say that time period is 40 seconds. So in 40 seconds, it goes, first reaches to the middle in 10 seconds, then it goes to the bottom in next 10 seconds, so total 20 seconds, and then in next 10 seconds it reaches to the middle again, so total 30 seconds, and then in next 10 seconds it reaches back to the starting position. So overall in 40 seconds it gets back to the same position. The total displacement covered by a particle. Let's say the amplitude of the wave is 10 millimeters. How much distance will be covered by a particle over here, let's say particle A, in one complete cycle? So first particle has to go over here 10 millimeter, 10 millimeter again 20, then 30, and then back to the starting position. So in one time period it covers 40 millimeters. So total distance will be 40 millimeters in one time period, and total displacement will be 0 because it returns to the same point. Okay, then we have something which is known as interference. So when two waves of the same type meet up at a point, they produce interference pattern if they have same frequency, same phase, constant phase difference, and same frequency. Okay, I said it already. They'll produce interference pattern. If they meet up at a point, they were of the same type, means they have same nature, and they were coherent. Coherent means same phase difference. Interference could be constructive or destructive. If the amplitude increases, the displacements combine and the amplitude increases, that is constructive. Otherwise it's destructive. Could be constructive, could be destructive. So interference, the waves of same type, or you can say nature, they meet at a point, they have constant phase difference, and indeed they must be having same frequency. If they have same phase difference, constant phase difference, they must be having same frequency. Also these are conditions for interference pattern. At a given point, how do we know if constructive interference happens or destructive? So for example, two waves meet over here. This is a point X. This distance is 15 centimeter. This distance is 20 centimeter, and the wavelength is of the two waves is 2 centimeter. Wavelength is constant for both of them, is same because the waves are coherent. At the point X, what interference takes place, constructive or destructive? So there is a method. If the two sources were initially in phase, somewhere in the question you read two sources are in phase, what happens then? N lambda equals to path difference. So what does that mean? Find the value of n. Lambda is 2, path difference is 20 minus 15, which is 5. So n equals to 5 over 2, which is 2.5. If the value of n is 0.5, 1.5, 2.5, 3.5, 4.5, it means destructive interference occurs at X. But if the value of n was found to be 0, 1, 2, any of these, then constructive interference occurs at the chosen point. The twist is these two rules will be flipped over. These two rules will be swapped if the two sources were initially out of phase. Rules swap means if the value of n is 0.5, 1.5 constructive, otherwise destructive. For double slit, we use a source of light. It first passes through the first slit to produce diffraction pattern. The waves bend and then they pass through two slits. This way they produce coherent waves. Now these two waves overlap and they produce interference pattern on the screen. So this is the screen at the back. They produce interference pattern on the screen. The central one being the bright spot. If it is light, this is bright spot, then dark, then this one bright again, then dark. The one I'm not drawing anything is dark one. Bright, dark, bright. So interference pattern is produced. The distance between any two consecutive bright spots is called fringe spacing, represented by x. The distance between the center of the two slits is called slit spacing, represented by a. The shorter distance between two slits and screen is slits to screen distance. And the formula is lambda equals to a into x over d. In many of the questions, x is found indirectly. So they might give you 1, 2, 3, 4, 5, 6. They'll say these lines represent bright spots and the distance is 10 centimeter. What is the value of x? Find indirectly. So how many times of x do we have? 1, 2, 3, 4, 5. So 10 centimeter is basically representing 5 times of the fringe spacing, because only this thing is fringe spacing. So x is 10 divided by 5, which is 2 centimeter. So x is 0.02 meters. Wavelength should be in meters. A is usually given in millimeters. You need to convert into meters. D is luckily given mostly in meters. Wavelength is given in sometimes in nanometers. So multiply by 10 to the power minus 9 to convert nano. Sometimes in pico. So multiply by 10 to the power minus 12 to convert pico into meters. If we don't have two slits, rather we have thousands of slits per millimeter. That case is known as diffraction grating. In that produces a pattern like this. The central spot is maxima is called n equals to 0. Then you get n equals to 1 at the top and at the bottom. So this one is n equals to 1. This is also n equals to 1. This one is n equals to 2. This is also n equals to 2. And the formula is n lambda equals to d sine theta. Lambda is the wavelength here. D is the slit separation. So let's say the question says the diffraction grating has 1000 slits per millimeter. So you need to find the value of d indirectly. How do you do? So number of lines per millimeter. How many? What is the distance? Given distance? Millimeter means 10 raised power minus 3 divided by number of lines 1000. So the general formula is the given distance divided by number of lines. Theta is the angle from this n equals to 0, the central fringe. So it's theta equals to, let's say 30, or let's make it more realistic, let's say 7 degrees. Now what does that mean? They can ask you probably to find the wavelength. So n equals to 1 because this is the angle for the first order maxima. It should be mentioned in the question that this is the angle for which order maxima. So if first, then n equals to 1. If second, n equals to 2. If third, n equals to 3. So this is very important formula, can be used to find a lot of things. And once again, n lambda equals to d sine theta. In order to find the maximum number of fringes, theta has to be taken as 90. In order to find total bright spots, the number of bright spots, the formula is whatever the value of n is, 2n plus 1. So let's say the value of n was 5. So 5 at the bottom, 5 at the top, and 1 so the center. So the total bright spots or total maxima would be 11. In order to find the total dark spots or the number of minimas, you simply do 2n because the minima, there is no minima at the center. So for example, if n is equals to 5, so the number of minima would be 10. If the same experiment is done with the white light instead, not with the single frequency but with the white light, it passes through the diffraction grating, then we get a pattern. The central pattern is white light. The central band n equals to 0 is white. Why? Because constructive interference of all colors takes place at the center. And then we get a pattern. Then we get a pattern. What kind of pattern do we get? We get a pattern in such a way that closer to the central would be violet. So this kind of pattern would be n equals to 0, n equals to 1 at the top and at the bottom, but the pattern of the colors would be red far away, red color at the top, and violet closest to the center on both sides. So violet closest to the center, violet closest to the center, and red further away. For CRO, cathode ray oscilloscope, if you need to find the time period, the formula is TBS, time base setting, multiplied by boxes for one wave cycle. If TBS is given in centimeters, time base setting is given in centimeters, then boxes, instead of boxes you say centimeters for one wave. How many centimeters are there for one wave cycle? If you need to find the frequency, first you can find the time period, then you can take the reciprocal. In order to find the amplitude, let's say maximum voltage or amplitude of the signal, what you do is you multiply y gain by number of boxes for the peak. Like the peak of the wave is for how many boxes, like this, and then you have small boxes. You can count the number of boxes that you take to reach the peak. If it is given in centimeter, y gain is given in centimeter, then you need to count the centimeters that you need to reach the peak.